Okay, so we talk about divide and conquer technique for solving certain type of problems. So basically it has 3 steps. So it is a design paradox, it has 3 steps. So first step, we divide the problem into sub problems. So that is the divide step. So basically, so we have a problem of size n, and we divide this problem into sub problems of lesser size, and then we solve these sub problems recursively, that is the conquer step. And then once we have a solution of these sub problems, then we combine these solutions to get a solution of the whole problem. Like for example, merge sort. So we have a sorting, that is a sorting problem. We need to sort a array of size n. So we divide that into 2 sub array of equal size, and we sort this sub array recursively, that is the conquer step. And then we call the merge subroutine to combine to get a solution of the whole array. So basically we divide the problem into sub problems of lesser size, that is important. So this is basically divide step. Then we conquer these sub problems by recursively solving them. Then we conquer the sub problems by recursively solving them. This is the conquer step. So divide, conquer step, and then we have a combine step. That means basically once we have the solution of the sub problems, then we combine the we apply the combine step to get the solution of the whole problem. So that is called combine step. We combine the solution of the sub problems to get the solution of the whole problem, solution to get the solution of the whole problem. So this is the combined step. So this is basically so any divide and conquer technique has 3 steps basically. We divide step, we divide the problem into sub problems. Suppose we have a problem of size n, we divide into the sub problems which is of lesser size. Then we recursively solve these sub problems by calling it the same function recursively, that is the conquer step. Then once we have the solution of these sub problems, we combine to get the solution of the whole problem. So this is basically 3 fundamental steps for any divide and conquer approach. So the example is merge sort, that is the divide and conquer technique. So merge sort is an example of divide and conquer technique. Merge sort. So basically it is a sorting problem. So we have so in merge sort what we are doing, we have an array of size n. This is the array of size n. We are dividing the array into 2 sub array, n by 2, n by 2, lower ceiling or upper ceiling, but if n is even, then n by 2, n by 2. So this is the divide step. We divide. So this is the divide step. We divide the divide the array into 2 sub arrays. So this is the divide step. We divide step is we just divide into 2 sub arrays, 1 to n by 2 and a n by 2 plus 1 to n. And the conquer step is we sort this sub array and this sub array recursively by calling the same merge sort. So, that is the conquer step. So, we are sorting this subarray 1 to this and we are sorting this right subarray. Okay. Now, once we have two sorted array, then we call the, this is the combined step, we call the merge. We call the merge subrouting to get a sorted array. So, we have two sorted array after this conquer step, then we call the merge subrouting to get a sorted array. So, this is the merge sort, and we know the recurrence is basically the T n is equal to 2 T n by 2 plus theta of n. Okay. So, any divide and conquer technique will have this type of recurrence. Here 2 is significant is number of sub problems. So, here in merge sort we have 2 sub problems, and this n by 2 meaning is size of the sub problems, size of each sub problems, size of each sub problems. And this is basically what? This is basically for merge sort, this is the cost for merge, because merge sort this divide step is very trivial, because we are just going into the middle, just n by 2. We are just identifying n by 2, that is it. It is very trivial step for merge sort, but this is crucial. This merge will take linear time, order of n, but this is cost for both divide and combine, because when you talk about quick sort, that is another example of divide and conquer technique. There this division, this divide step is more expensive than the combine, because divide step we need to call what is called a partition subroutine. We will partition this array. So, this we will discuss at the time of quick sort. So, this is the time for both the step, both divide and combine. This is important. So, this is the any divide and conquer approach having this type of recurrence, where that cost will be denoting by the cost for both the merging both the both the division, divide and combine. Here division is trivial, just a theta 1. Here this for merge sort this is theta 1 and this is theta n. So, together will theta n, but when we talk about quick sort, this will be theta n and this will be nothing, theta 1 maybe. Okay. So, this is the this is one of the example of divide and conquer technique. So, we will discuss some more problem which can be solved using this technique. So, let us start with a very simple one, the binary search problem. Okay. Binary search problem. So, what is the binary search problem? Binary search problem is basically we have a sorted array, that is the input, and we have another input as a key, and we need to find the key whether this is in the array or not. So, the input is we have a sorted array, we have n numbers which is sorted, and then another we need to search a, and the problem is to search a value, search a key in the search a key, another input. This is also another input. This is another integer or real number. We need to search this whether this is present in the array or not. Search key in the array. So, this is the problem. Okay. So, how we can do this search? So, if the so what is the naive approach? If the say if we have an array, so we can just do the linear search, just for I is equal to 1 to n, we just check whether key is equal to ai or not. Very simple one. This is the search. This will take theta of n time, because we are not bothering whether they are sorted or not, but we have a information that they have sorted. So, that is why we need to make use of that that they are sorted. So, for that we will do the divide and conquer technique. So, what we do, we just this is the array, A array which is sorted. So, this is basically middle one, n by 2 or lower ceiling or upper ceiling anyway. So, now we compare our key with this value. If key with this value a n by 2, okay. If key is equal a n by 2, then we are lucky, we just return this, we got it, first sort, best case. But if key is, there are 3 possibilities, equal to, we are happy, otherwise if key is less than this. Okay. Suppose this array is say 3, 4, 5, 7, 9, 10, 11, and suppose we are looking for say 4 or we are looking for say 5, suppose our key is 5, we are looking for 5. So, we check with the middle one is 7, this is 7. So, key is not, so 7 is not 5. So, then what we do? Then we know this is sorted. So, 5 cannot be in the right part of the array. So, 5 has to be in the left part of the array, if at all it is there. So, then we must look at the left sub array with the same key. So, that is the conquer step. So, divide step, we just compare with the middle element. If the middle element is equal, then we return it. If the middle element is less than, then we look at the right part of the left part of the array, and if the middle element is greater than, suppose we are looking for say 9, then we must look at this part of the array, because we know the 9 cannot be in the left part of the array. So, we will look at the right part of the array. So, this is what is called binary search algorithm. So, this is basically a divide and conquer technique. So, in the divide, it is very clear, in the divide step we just go to the middle of the array element a n by 2, we compare with the key. If the key is matching, we are happy. So, we return the key, this is the best case. Otherwise, if the key is less than that value, middle one, so we must have to look at the left part of the array, that is the conquer step. Then again we will search it in the by taking the left sub array. So, we reduce the problem into sub problems, and then if it is greater than, we look at this. So, this is the divide and conquer technique. So, then what is the recurrence then? So, recurrence will be T n is how many sub problems, either we are going for left or we are going for right. So, we are again calling this search either on the left side, worst case, best case we are getting immediately, or in the right side. So, this is basically T n by 2 plus theta of 1, because just a one comparison we are doing with the middle one. So, that comparison anyway, we do not bother about which computer we are checking this comparison, whether Pentium 1 processor or CoreDuo processor, because that comparison will take constant time. So, that is the asymptotic notation we are going to use, a good friend. Okay, good. So, this is our basically recurrence of this binary search. Now, how to get the solution of this recurrence? Again we will take help of the what is called master method. So, how to get the solution for this? So, if we compare with this, let us recall the master method. So, master method recurrence is a T n by b plus f of n. Okay. So, it has 3 cases. Case 1 is f n is basically big O of n to the power log a base b minus epsilon. So, that means this is more, then the solution is Tn is, so big theta of n to the power log a base b, and case 2 is basically what? Case 2 is their growth is similar or they may vary in the log factor. So, this is basically Fn is big theta of n to the power log a base b into log n base 2 to the power k. They may vary in a log factor or power of log factor. So, in this case solution is basically big theta of n to the power log a base b into log n base 2 to the power k plus 1, and this k is basically 0 1 like this. And then we have a third case. So, we will come back to this case 3, which is Fn is more. So, Fn is big omega of n to the power log a base b plus epsilon. So, here epsilon is positive, and we have a regularity condition like a f of n by b must be less than some c of Fn, where c lies between 0 and 1. This is the regularity condition we have. So, in that case solution is basically big theta of Fn. So, this is master method. Okay. Now, so now we have a recurrence what? We have a recurrence Tn is equal to 2 Tn by b, sorry, the binary search Tn by 2 plus theta of 1, that means c, just a constant, or you can write theta of 1. Okay. Now, what is A? A is 1, what is B? B is 2, and what is Fn? Fn is basically constant, theta of 1. Now, we need to calculate n to the power log a base b, n to the power log a base b. This is basically n to the power 0. So, this is basically 1, and Fn is also constant. So, which case we are in? We are in case 2 with k is equal to case 2 with k is equal to 0. So, case 2 with k is equal to 0, then what is the solution? Solution will be Tn is equal to big theta of n to the power log a base b, that is basically 1, and log n base 2. So, this is the solution for the binary search. Okay. And this we are getting by the help of master method. Okay. Now, let us talk about another problem which can be solved using the divide and conquer technique, which is called say powering a number. So, this is how to find a to the power n, say 2 to the power 1000 or 5 to the power 100. So, this is the second problem, powering a number. So, basically we want to find a to the power n, say for example 2 to the power 100 we want to find, or say 5 to the power 50, something like that. So, a to the power n, where a or n are both the integer. Okay. So, then what is the a to the power n? This is the problem. Given a, given n, we need to find a to the power n. So, this is the problem. So, what is the naive approach? So, a to the power n basically a into a into a into a, n times a. So, this is basically a for loop, just simple code for I is equal to. So, before that we need to take this thing x equal to 1, and then for I is equal to 1 to n, x equal to x into a, that is it. So, then this is the code, then return x. So, x is basically a to the power n. So, then what is the time complexity of this code? How many matrix multiplication? Sorry, not matrix. How many multiplication we are happening? So, multiplication we have n multiplication. This is a loop of size n. We have n or n minus 1 because this is a to the power n. So, we have order of n multiplication, and again each multiplication is taking theta of 1 time. Again we are in asymptotic notation. We do not care about how much time our hardware is taking to multiply two numbers, two integers. So, that time we are not really bothering. So, that time we are treating as theta of 1. So, this is time we are treating as theta of 1. So, that is the asymptotic sense. So, this algorithm is basically theta of n algorithm because we have a loop of order n. Now, the question is whether we can do something better than this. So, now particularly now the question is whether we can have a divide and conquer approach to solve this problem of powering a number. So, that is basically the idea is if we have to find 2 to the power 100. So, this we can find 2 to the power 50 and then we multiply it with it 2 to the power 50 again. So, that way. So, we have a problem of size 100. So, we reduce this problem into sub problems n by 2 like this. So, that is the idea. So, let me write the divide and conquer step. So, this is the divide and conquer step for this problem powering a number. So, what we are doing, a to the power n can be written as a to the power n by 2 into a to the power n by 2 if n is even, otherwise it is a to the power n minus 1 by 2 into a to the power n minus 1 by 2 into a if n is odd. That is it. So, this is the divide and conquer step. So, basically this formula will give us the algorithm. This is the divide and conquer step. So, we have a problem of size n, we need to find out a to the power n. So, instead of finding a to the power n, we divide this problem into sub problems. We will find a to the power n by 2. Then once we get the solution of a to the power n by 2, we multiply with itself. Then that will give us the. So, what is the divide step? Divide step is basically we just get a to the power n, we just get n by 2, and the conquer step means we just try to get a to the power n by 2, that is the recursive call. And then once we have the solution, then combined step is this multiplication if it is even. If it is odd, then what we have? If it is odd, we have a to the power n minus 1 by 2, this is the divide step, and then we recursively call this a to the power n minus, that is also we reduce the problem into sub problems of size n minus 1 by 2, and then combined step. Here we have, if it is odd, we have 3 matrix 3 multiplication, this with itself and with a. Okay. So, then what is the recurrence? What is the recurrence? So, how many sub problems? 2 sub problems. So, T n is basically 2 T n by 2 plus then the divide step and combine step. So, even if it is even, we have only 1 multiplication, even it is odd, we have 3 multiplication and the divide step is nothing. So, that is basically theta of 1. Is this recurrence is correct? No, this is not correct, because how many sub problems? Do we need to really calculate twice of this? Because once we calculate this value a to the power n by 2, then we can store it. We do not need to calculate it twice. So, these 2 will not be there. So, we are basically 1 sub problems. So, if we calculate a to the power n by 2, it store it somewhere and we multiply it with itself to get the for the combined step, that is it. So, this is the recurrence. Now, what is the solution of this recurrence? This recurrence we have seen just now for the this thing for the binary search method. So, this is basically the log of n. Okay. So, this is a powering a number. Now, here we are assuming these numbers are integer. But what if the numbers are not integer? Then the problem is, suppose we want to find out, say, suppose we want to find out, say, 0.329 to the power, say, 500 or say 100. If we are dealing with the real numbers, then the issue is, so then it will be divided. So, this is a to the power n, where a is a real number. If it is a real number, then the problem a positive real number, otherwise we will have the imaginary part of it. So, anyway, so then the problem is a to the power n by 2 will be a real number. Say suppose this is say 1.9123, then say, and this is also this. Now, if you multiply two real number, then we have to think of their round offing, precision. So, these are all the issues will be involved when we deal with the real number. So, that will take more time than these steps. So, then only the multiplication. So, that is why this powering a number, we restrict ourselves on a to the power n, where a is a integer. So, otherwise we have to deal with the real number, precision, round off, all these things will be coming. Okay, thank you.